Hello dear students, let us solve this question. This question says a charged shell of radius r carries a total charge q given phi as the flux of electric field through a closed cylindrical surface of height h. That means let's say this is a spherical shell having charge q. Phi as the total flux, this phi is the total flux of electric field through a closed cylindrical surface of height h, radius r with its center same as that of the shell. That means this will be the cylinder here, and this cylinder based on its height and radius will be enclosing this shell inside or outside. Here center of the cylinder is a point on the axis of the cylinder which is equidistant from its top and bottom surfaces. That means the cylindrical placement of the cylinder is symmetric here with respect to center. So this center is the center for both the spherical shell and the radius. Which of the following options are correct? So if you see, each and every option is having different value of height of the cylinder and different value of radius, so we will have to check each and every option here. So if you see, the first option says that h is greater than 2r and r is equal to 3r by 5. This means this r is less than capital R or the radius of the shell. So in this particular case, we will have to find out the flux. For that, let us draw the shell here. This shell and the cylinder, this is the placement of, let's say, the cylinder. Since height of the cylinder is greater than 2r, so this will be the appropriate figure here, and this is the center. Now for finding the flux through the cylindrical portion, we'll have to find out the charge enclosed in the cylindrical portion. So this means this shaded portion, the charge, the part of the total charge we can say of the spherical shell which is basically lying inside the cylindrical surface, and this charge will be equal to, let's say this is q enclosed, will be equal to q by 4 pi r square. This is basically the charge density of the shell into the area of the shaded portion. That total area will be equal to 2 into 2 pi r square into 1 minus cos of this angle. By geometry, we can say that, let's say this is r and this is given to be 3r by 5. By geometry, we can say that this angle here is basically theta. This theta here is equal to 37 degree, right? So if we simplify it further, we will get q, this will cancel out this, and 1 minus cos 37 is basically 4 by 5, and this will be q by 5. So that means 1/5 of the total charge will be lying inside this cylinder, and flux in this particular case will be equal to q by 5 epsilon naught. So option first seems correct here. If you see the second option says that h is less than 8r by 5, r is equal to 3r by 5, and phi is equal to 0. If we see this option, and let us draw the figure for this. So let us first try to see the location of cylindrical portion. So here h is less than 8r by 5 means this can be inside also, totally inside the spherical shell, or some part of it can lie outside also. For that, let us take the case of limiting cylinder having radius 3r by 5. So that will be, let's say, this cylinder. This is given to be 3r by 5, and this height will be basically half of this 8r by 5. That means this is 4r by 5, and this will be r. So as we can see that the height of the cylinder will be exactly 8r by 5, the limiting height for this radius 3r by 5. That means if this height is less than 8r by 5, this says that the cylinder will completely lie inside the spherical shell. So there will be no charge enclosed inside the cylindrical surface. That means flux for this particular case will be equal to 0. So this also seems correct. Now if you read the third option, the third option says that if h is greater than 2r, r is greater than r, then phi is equal to q by epsilon naught. So this is very easy to visualize. We can say that if this is the spherical shell and the cylinder is having height which is greater than 2r and the radius of the cylinder is also greater than capital R, that means the cylinder here will be lying completely outside the spherical shell. That means the total flux which is emitted by the spherical shell will be passing through the cylindrical surface only. So for this particular case, phi will be equal to q by epsilon naught. So this also seems correct here. Now if you see the last option says h is greater than 2r and r is equal to 4r by 5, then phi is equal to q by 5 epsilon naught. So if you compare this option with the option given in first, height is greater than 2r for both the cases, but here the radius is greater than 4, radius is equal to 4r by 5, which is greater than basically 3r by 5. That means I can write here that this r is basically greater than 3r by 5 since this is 4r by 5. So in this particular case, the charge enclosed by the cylindrical surface will be more than q by 5 here. So this is the amount of charge which we have got in the case first. So for the case 4, the charge enclosed will be more than q by 5 epsilon naught. So we can say the flux will be more than q by 5 epsilon naught. So phi for the fourth option will be greater than q by 5 epsilon naught. So this seems incorrect, right? So for this particular question, option 1, 2 and 3 are the correct options to mark. Thank you.